what is really missing are the microplastics, which are defined as particles, plastic particles that are smaller than 5 millimeters in diameter. And it has a big range. So from 5 millimeter down to 1 micron. So my hair is probably like 500 micron or so in terms of diameter. So 1 micron is very, very small. And this huge range of plastic particles are all defined as microplastics. Why are they very dangerous? Is one, because they are invisible to the naked eye, especially when they're going to the sub-millimeter scale. And two, they are everywhere. They're in our all of our oceans and in more than 90% of the drinking water sources. And they're in our blood. So at the beginning you were asking like, okay, there are a lot of like news coming out about microplastic being in our body, and that is fully evidenced now. Like they're in all kinds of organs. They're in the brain, they're in the breast milk, they're in the blood tissues. Because they're so small, they're smaller sometimes than the cells. So they can penetrate between and then stay in the body.
You're listening to Foreign Founders. We tell stories of immigrant and first-gen entrepreneurs, investors, operators, and ecosystem builders. And on the show, you hear incredible stories that often go untold. Yidian Liu is the co-founder and COO of PolyGone Systems and a Forbes 30 Under 30 fellow. PolyGone Systems is a Princeton University spinout cleantech company with a mission to remove microplastic pollutants from our waterways. Yidian was a trained designer with a master's degree in architecture from Princeton University, and since 2021, she and her team have won over $2.4 million in grant awards and have successfully raised their pre-seed venture capital funding. On this episode, we're covering everything microplastics, from what it is to the PolyGone solutions. Welcome to Foreign Founders, Yidian.
Hi, Andy. Thank you so much for inviting me to the podcast. Very, very exciting to be part of this.
I'm excited as well. We've heard microplastics in the news for the last couple of years. So this might be on a lot of people's mind. But before we get there, tell us more about you and your background. Where did you grow up?
Of course. I was actually a trained architect. So the first question people may be very curious is, what is the relationship between an architect and solving microplastic? What made the decision of the transition? So I would say originally I grew up in China, and I'm like always very excited about our building environment, and I believe in the value of design. I always imagine like utilizing design as a tool to advance the physical environment that we live in. So that kind of inspired me to study architecture for my undergrad and also my graduate degree. But one thing I was like noticing when I was doing this career path is like everyone in the architecture space is very kind of aesthetics focused or historian theory focused. Everyone is very obsessed with the speculative future rather than the reality of where we live in. And that really becomes a strong feeling I have when I was working in a lot of offices. People care about the facade material, like the fancy toilet on the wall. But no one was really caring about, I believe, the most essential part, which is the infrastructure, the ugliest of the urban environment.
The plumbing, almost.
The plumbing, right? Yes. The smelly part of the city. Yeah. So I was really excited about, okay, can we actually utilize design to change how the current ugly size of the city? That kind of triggers me to study at Princeton for like this very specialized focus. And originally I was picking plastic waste, plastic recycling facility as my focus, because back then it was beginning of COVID, and you can see like plastic being like drastically increased in the just in the town, everywhere is just full of plastic waste. And I
Hmm.
always hate plastic. So I was
Hmm.
thinking, okay, if we can advance the plastic recycling facility, would we have a chance to really eliminate it in the entire lifespan of plastic? And in that research, I realized that there are already a lot of like advanced sorting and recycling technologies out there, and people are already doing a lot of great stuff. Um, I think what is really missing are the microplastics, which
Hmm.
are defined as particles, plastic particles that are smaller than 5 millimeters in diameter.
Yep. And 5 millimeters, what's the equivalent of that? I think it's like grain of rice or
Grain of rice, I
smaller,
would say,
right?
yeah, smaller
Yeah.
than that. And it has a big range. So from 5 millimeter down to 1 micron. So my hair is probably like 500 micron or so in terms of diameter. So 1 micron is very, very small. And this huge range of plastic particles are all defined as microplastics. And why are they very dangerous is one because they are invisible to the naked eye, especially when they're going to the sub-millimeter scale. And
Right.
two, they are everywhere. They're in our all of our oceans and in more than 90% of the drinking water sources.
Hmm.
And they're in our blood. So I at the beginning you were asking like, okay, there are a lot of like news coming out
Yeah.
about microplastic being in our body, and that is fully evidenced now. Like they're
Yeah.
in all kinds of organs. They're in the brain, they're in the breast milk, they're in the blood tissues.
Yep.
Because they're so small, they're smaller sometimes than the cells. So they can penetrate between and then stay in the body. So
Yidian, I went down a rabbit hole on like looking at microplastic information, and it's like, yep, it's everywhere. It's in like 9 in 10 adults, 8 in 10 like babies. Like, oh my gosh.
it is, it
Yeah.
is. And then this year, I think a lot of people got like a refresh memory of microplastic because Nature has a new publication on microplastic, I believe in like brain cell or in one of the organs. And then the studies we learn now is that the quantities of microplastic and the size of them in the human body tissue has increased drastically since we last have those studies, which is like a few years ago. And accumulation of them in the body is something it's like a bomb. We don't know when it's gonna kick. And do we really want to wait until that point when we really can't do anything about it? I think the fear and the stress of this issue really kind of triggered myself and my co-founder to innovate a system that is design initiated, physical, and then kind of easy to assess compared to some of our existing filtration systems. And that was the base of PolyGone. So we kind of innovated a prototype when we were in university, and then that idea was widely hated by by our department at the beginning because they think designers should not be too dedicated into solving a problem. At most, we can use design skills to advocate for it, like raise awareness. But for us, we don't think that's enough. We want to take a step further. And we did not listen to their advice. So we kind of reach out to a lot of very smart people from the engineering departments and kind of collaboratively innovated the very first prototype of our plastic system.
So you got told to stay in your lane, essentially. Was
Exactly.
that advice? Yeah.
Exactly. Yeah. I think a lot of a lot of scholars, especially in academia, they want the purity of a research. They do not want anything that has like a practical value because that kind of limit. I understand why because that limits the imagination scale of that project.
What was your, I guess, you and your co-founders' impetus to make real life change? Like, did that come from, uh, mentorship, how you were raised, like all these things? What was that moment from like, because you could have gone down the academic route and being an academic, right? but you wanted to build something real. What was that difference?
I guess it's a mentality since a young age. I hate waiting for other people to do something. I am
Yeah,
always the one, if I want to do something, I want to do it tomorrow, today, you know?
yeah,
So that is just me. And my co-founder, he's very obsessed with any kind of industrial systems. He likes to see things in reality. And we're both a little bit impatient.
that's what you need to make a change. So when you were doing the first research you were doing was basically, oh, is there anything that we can do with plastics and recycling? Then you saw that there's a lot of solutions out there that's kind of working, but then the microplastic part, were there any existing solutions that we people or like towns or treatment plants were employing?
Yes and no, right? So for example, if you walk through like a large river, sometimes you see those kind of floating barriers, and that kind of like it has a lot of trash basically being stopped by that floating barrier. And that is like somehow effective for some of the microplastics. I would say the larger one. So from 1 millimeter to 5 millimeter, this range, a lot of them can be captured. But the ones that really go through the body, like would not be captured by those kind of simple systems. And then the existing solution water treatment plants include like reverse osmosis, those kind of very fine mesh systems. But at the
Hmm.
same time, they're very expensive and very energy intensive, not very easy to install. And not all the township has the budget or space to host
Right,
those.
right.
Yeah. So our value proposition was really trying to be like a accessible solution that is not one of those very fancy, very fine meshed solution, but it's easy, plug and play,
Yeah.
plug and play into the existing infrastructure or reverse. It becomes something that's very versatile.
And what was Polygon's first prototype? What did you build to make that happen or prove that out?
It was actually very stupid. It was literally a floating wetland. At the beginning, I did a reading into a research. So they're using aquatic plant root to kind of become like a green infrastructure, and that can absorb a lot of micropollutants in the river or in like wetlands. I was like, okay, that means smaller pollutants are entangled in the fiber structure of that. That must be a great idea. So I literally bought a lot of aquatic plant root and started plant them in my apartment, and I have like loads of them. And they are very effective in collecting microplastic. But the plants keeps dying, and I just like could not make them survive. And it's not just the plant, but the entire ecosystem. My little snails that I had like pet snail in the aquarium are all dying altogether. So I did like a interview with someone who is doing water like closed water system treatment, like lake treatment, and they told me floating wetland are very hard to maintain, and then they quite often become habitats for wildlife. So it's not very practical solution for microplastics. So we are like we love the idea of the aquatic plant root. Can we make like a non-dying aquatic plant root, but have the same structure of that filament aspect? And then that is what inspired us to have the current system. It's called a artificial root filter. So it's basically like a very fibrous structure made with different material that's artificial. So it's gonna do the same job, but it's not gonna die.
What it looks like too, when I was like on your website for
Mm.
the viewers or listeners, it almost looks like a vertical, like those scrubbies when you go through a car wash. Yeah. Right? It's like a vertical thing with a lot of different like pieces out of it.
Yes. But
And
When I actually washed the car, I was telling my co-founder, I feel like I'm the microplastic. That was the process being collected.
Yeah. Yeah, I saw that image. I was like, oh, interesting. So these this product that you have is a removal product. It basically removes microplastics from water solutions. Your the companies that employ this, do they like install it at a in the water plant? And how does it work exactly?
Yeah, so we have that root filter kind of in an array or like in a network. So it kind of covered the entire cross section of whatever water channel there is. And when the water channel like has water flowing through the system, the microplastic got kind of entangled in the array of the filters, and then the clean water comes out. It's a very passive system in comparison to a lot of the more kind of active forced system.
Yeah. And would this be considered like the first layer of defense, the last layer of defense? Like what, where does it sit?
It sits after the secondary treatment, so when the majority of the other solids are being removed on the water treatment process,
Gotcha.
the water is like relatively clean, but microplastics are not being removed yet.
Got it. And last thing, these like artificial root filters, from the videos that I saw, it looks like it's only maybe like a couple feet into the water, right? It's
Yeah,
not all the way down. Is
yeah,
that because microplastics are like usually closer to the top?
that is correct. Because if we look at the densities of plastic, a lot of them are lighter than water. And then even the ones are denser than water, because how small they are, a lot of times they are being captured by the surface tension of the water. So they
Hmm.
like to stay on the top 1 foot or so of the water column. I wouldn't say that's all of the microplastic, but that's the majority of the microplastic. And then, so our filter does not need to be super long to entangle those. We just need to cover the interface between the water and air and then the top water column.
That's amazing. Correct me if I'm wrong. I saw on the website too that there
Mm,
are two other products or solutions that you have. One is the monitoring. It seems like a floaty device with a root on it.
yeah.
And then the second one was lab analysis. So is that something that I can like basically take a filter water and then send it to you for analysis to see?
Yes, feel free to send water to our lab. Yeah, there are many ways nowadays to test microplastic quantities. So, for example, you can the the least precise way would be you're just using your naked eye to look at
Yeah.
it, calculate them. And then we're utilizing a few methods. So the first one is like using like a special dyeing material that dyes that only reacts to plastic. And then under a certain wavelength, this material will reflect in that channel. And we
Yeah.
can take a picture of that petri dish surface, and then we can run a script to calculate how many plastic particles are there. And then a more advanced process will be using the machine called FTIR or Raman. So those are basically firing different light at the particles, and then based on the wavelengths of those receiver end of the equipment, there's like a chemistry composition range of that
Hmm.
wavelengths. So that's a more advanced way of like analyzing microplastic.
And both of those, the cost is like drastically different between those two solutions.
Right. So for the advanced machine, because the machine and the labor associated with that will be more expensive than the dyeing method.
Yeah.
The precision will also be higher.
Do you this is fascinating to me, and clearly with the questions I am asking, I'm like very interested in what's going on in the water system. Um, do you know roughly, like by regions, how bad the percentage of tap water microplastics are? or is that by like treatment regions? Like how do you define those?
It's drastically different because every treatment plant has different treatment process. So we cannot tell like how much microplastic are there. Even the same plant would have variance on a daily basis.
Got it.
Yeah.
So you and your co-founder found this problem, created a prototype, experimented it, but the first version, like they died. So you created these artificial root filters. What was next? With Princeton, did you go out and like find treatments to sell this into? Like what happened?
Yeah, we went to a lot of like customer discovery trips. We went to a lot of conferences. We talked to like more than 100 potential customers, mainly the treatment the treatment decision makers, I would say. And one of them said, "Yes, let's try it." When we literally just started the business. So we showed them our prototype, and then together we worked on like a proposal to build a like industrial scale pilot at their facility, and
Hmm.
then we successfully got the funding. So in 2024, we built the first industrial pilot. And now we're working together on the stage two of that pilot to make it more automatic.
So 2021, you started this project.
Yeah.
2024 was the first pilot customer.
Exactly. 2021, we graduated.
Yeah.
2022 was actually the first year we run the business because my co-founder and I need to survive. So we find we find a job, and we can only moonlight after the work hours. We did that for like almost a year before we got the funding
Oh
from
my
the
gosh.
investors.
Okay.
Mm.
And this is also one of those things where an immigrant founder is like different than, let's say, a native born founder because you can't, with a certain visa type, you can't charge, you can't make money.
Yeah.
So you're basically working for a company, moonlighting. And then what was that breakthrough point of saying, hey, we can actually do this full time?
It was completely random. My original plan was to work 2, 3 years, so it gives us more time to do the foundation of the business before we become independent.
Yeah.
But my office was a little bit tricky in supporting me in the H-1B visa lottery.
Hmm.
I assume most of the audience today know what the working visa is.
Yeah.
Anyhow, they did not really want to sponsor that unless I sign a very unfair agreement with them. So
Hmm.
I was very fed up with it. So I decided no matter how Polygon goes, I need to quit this job.
Hmm.
So at that moment, we were very lucky to talk to our initial pre-seed investor, and then they saw how determined we were, and they decided to fund the pre-seed, and we decided to go full time.
Yep. And this investor, they end up funding all of your pre-seed or just partially as well?
They fund all the pre-seed.
Yeah. So that was also being like, hey, we have an investor. They funded everything. We can figure out what comes after with this
Yes.
funding.
Yeah. Yeah.
Um, yeah, those are definitely challenges that we on the show like hear so often.
Yeah.
And there's yeah, and then there's always that moment or multiple moments, like especially like having funding, huge, being able to determine your own or have a say in your own like legal status, um, is a big moment. We're coming towards the end. One of the things that I'm very curious about is like how long do these pilot projects with
Mm.
Polygon, with these water treatments take? And what are like the metrics that you show to whether you're like pilot customers?
Yeah, that's a great question, actually. From actually the beginning of the design till the end of building, it's only 6 to 9 months. So Nathaniel and I I think the one advantage we have is we're very fast at design and we know how to procure all the parts and get it built quickly.
Yeah.
We don't need to have the back and forth process with the engineers, etc. Um, and now we're trying to streamline this process to make it more modular. So we only need to design the anchor system, but everything in between is modular. And that would make it less than 3 months from the beginning of design till the delivery. Most of the time is actually in the procurement and manufacturing. So the more modular we can make it, the smoother this process is going to become. And the report on efficiency, we do samples analysis based on our filter. So we analyze how many microplastic we collect in our cleaning basin. So the current one, I believe we're collecting 600K or so microplastics per wash cycle. So
Okay.
wash cycle means every time we clean the filter, that's a wash cycle. And currently
Gotcha.
we're cleaning it every week. And the stage 2 of this pilot is so exciting because we're making this process automatic. That means the system can be cleaned multiple times a day. That would drastically increase how much microplastic we can collect on that affluent channel.
That's incredible. To close out the show, I always ask founders, what are you
Hmm.
optimistic about? And I would love to ask you that. But before that, for me, like even hearing that there are solutions where we can make our drinking water cleaner, that is an incredible feat. So thank you for being on the show. But to close it out, what are you optimistic about, Yidian?
I'm optimistic about how quickly people are understanding microplastic as a big threat. I'm optimistic that this would become a joint value for a lot of people in our society. We want to
Hmm.
get rid of microplastic and we're actively seeking solutions for it. It is different from some of the less known pollutants that
Hmm.
it has a very difficult chemical compound that a lot of people are just finding it difficult to comprehend. Microplastic is so simple, so powerful, so just by its name, so dangerous
Yeah.
that people are looking into it and seeking for solution. And we, as a team, are very optimistic that we can be part of the game to be very active in providing those solutions.
Yeah, absolutely. I agree with you. Um, if people want to reach out to you, Yidian, or work with your company, PolyGone,
Mhm.
what's the best way to do that? Where do you want to send them?
I think the best way is just to go to our website and there's like a contact form or there's like info at projectplastic.site as our company email. I'm very responsive on all of our social media and on email as well. And I love to talk to people. I love to learn about what is in their mind. What do they think about microplastic all the time? So love to follow up with anyone who's interested.
Well, thank you so much for being on Forum Founders.
Thank you. Thank you. It was really nice talking to you, Andy.